let's find the arc length of y equals to f of x equals to x to the 5th power divided by 6 plus 1 divided by 10x cubed over the interval 1 to 2. So recall that the arc length formula is the integral from a to b of the square root of 1 plus f prime of x squared. In our case, a is 1, b is 2, and f of x is written right here, x to the 5th over 6 plus 1 over 10x cubed. So the first thing we have to do before differentiating this function is rewrite it, make it easier to differentiate. Write it as 1/6 x to the 5th plus 1 over 10 x to the negative 3rd power. And now differentiate this. F prime of x is equal to 5 over 6 x to the 4th minus 3 divided by 10 x to the minus 4 power. And let's rewrite that. F prime of x is equal to 5 over 6 x to the 4th minus 3 divided by 10 times x to the 4th in the denominator. The next thing we do is square the derivative. So f prime of x squared is just going to be the derivative, which is 5/6 x to the 4th minus 3 over 10x to the 4th squared, or multiplied by itself. So 5/6 x to the 4th minus 3 over 10x to the 4th. And this is equal to, let's go ahead and expand this, 25 over 36 x to the 8th power. And then 5/6 x to the 4th times minus 3 over 10x to the 4th, x to the 4th cancel. We get minus 15 over 60. We get it twice. Once for this 5/6 times this minus 3 over 10 term, and then once for this minus 3 over 10 times this 5/6. So this is minus 15 over 60 again, and then plus 9 divided by 100 x to the 8th power. Now let's simplify this. Minus 15 over 60 minus 15 over 60 is minus 30 over 60, or minus 1/2. So this is 25 over 36 x to the 8th minus 1/2 plus 9 divided by 100 x to the 8th power. Now let's take 1 and add f prime squared to it. Adding 1 will take this negative 1/2 and turn it into a positive 1/2. So 1 plus f prime of x squared becomes 25 over 36 x to the 8th plus 1/2 plus 9 divided by 100 x to the 8th. Now if we take this and put it under a radical without simplifying it any further, it'll be extremely difficult, if not impossible, to integrate. However, we recognize one thing. When we take f prime of x and square it, notice we have a minus separating the two terms. So one term is subtracted from another. And that gives us this expression with minus 1/2 in the middle. Here we have exactly the same expression involving the x terms, but plus 1/2 in the middle. So that is still a perfect square. All we have to do is go back to this original squaring of the derivative and replace the minus with a plus, and we have simplified this complicated expression. So this expression is actually equal to 5 over 6 x to the 4th power plus 3 divided by 10 x to the 4th power squared. And that's the key step right there. Now we can go back and integrate this. The arc length is equal to the integral from 1 to 2 square root of 1 plus f prime of x squared, which is 5 over 6 x to the 4th plus 3 divided by 10 x to the 4th squared dx. So square root and square, of course, cancel. And we end up with a very manageable integral, which is the integral from 1 to 2 of just 5 over 6 x to the 4th plus 3 divided by 10 x to the 4th dx. And let's rewrite this as integral from 1 to 2, 5 over 6 x to the 4th plus 3 divided by 10 x to the minus 4. And now let's go ahead and integrate this. So this is 5 divided by 6, and then we have x to the 5th divided by 5, so 5's cancel here, plus 3 divided by 10, and this will be x to the negative 3 divided by negative 3. So we can cancel the 3's, but minus stays behind. So we end up with this 1 over 6 times x to the 5th minus 1 divided by 10 x cubed, and that's evaluated from 1 to 2. Let's go ahead and do that. Plugging in 2 for x first, we get 32 divided by 6 minus 1 divided by 80. And then minus, plugging 1 in, that's 1 over 6 and minus 1 divided by 10. So let's do a little algebra to solve this. 32 over 6 minus 1 over 6 is 31 divided by 6 minus 1 divided by 80 plus 1/10, which is 8 divided by 80. So our answer is 31 over 6, and this is plus 7 over 80. Let's have a common denominator. Common denominator will be 240. So 240 will multiply the first, the 31 over 6 term by 40, so the 1240 in the numerator, and we multiply the 7 over 80 term by 3, so that would put 21 in the numerator. So the final answer is 1,261 divided by 240, which is the arc length of this function over the interval 1 to 2. For more videos, visit www.mathprepvideos.com.